All right, here's 2-6. Just a single day for 2-6. Combinations of functions and composite functions. So really, it's basically doing operations with functions, okay? Which is probably going to feel fairly familiar. We've done a couple of them a little bit, not a ton. So we'll break it down into kind of 5 of them. Add, subtract, multiply, and divide. We'll see a couple examples of those. And then the last 2 slides, we'll get into function composition, okay? First off, just how it's done, and then a little explanation of that as to when it would come up and why it would be done. All right, first thing down here on this side is just adding and subtracting. You basically play a little game of combining like terms, right? We're going to get f plus g of x. I say just put them in parentheses just to be careful. The parentheses might be meaningless. You could certainly look at the 2 functions and figure that out ahead of time if they're relevant at all. Like in this case, they're not. There's a positive 1 out in front. So I'm not going to rewrite it without them. I'm just going to ignore them. So I've got an x squared. No like terms for that. Got a pair of 2 x's, that'll be 4x, and then plus 1 minus 1, okay? So that function is f plus g of x. That's just its name. It's the sum of the 2 functions that were defined as f and g. But now it wants me to find f of g of 4 or 3. Not 4. 3. But as you're doing that, you should know that you evaluate it just like any other function. You just plug in x, because we're looking to see what are we going to get for y. This comes out to be 9 plus 12, 21, right? Plug in 3, get 21 for an answer. But really, in terms of the algebra, I hope you saw there that it's basically combining like terms. Subtraction is no different, right? We got a couple polynomials here, a line and a quadratic. Squared terms can get combined with other squared terms. Terms with just a single x can go with other x's, and constants can go with constants, okay? You've seen that many other times in algebra courses. That's how like terms get combined. Little bit of work to do with the parentheses. I can just drop the first. The second set needs the negative sign distributed before I can start to combine, because that negative sign applies to all 3 terms that are in the parentheses. Okay? All right, just need a little more room. We've got the function. It's a quadratic, negative x squared plus 2. Now it says to evaluate that function at 2, which would be negative 2 squared plus 2. And for our y value, we would get negative 2. Okay? I think you'll probably see of all the function operations, adding and subtracting probably the most basic. It's not like a crazy new, unfamiliar method as far as how we do it. Right? Probably feels pretty familiar. All right, let's do some multiplication. f times g of x. Here's f. Here's g. And with multiplying, it turns into a little distributive problem. I'll get x to the third minus 3x squared, and there you go. There's f times g of x. It's evaluated at 4. Which should be 4 to the third power minus 3 times 4 squared. Four to the third is 64. 3 times 16. (64 minus 48), 16. Okay? Plugged in 4, right? It's always worth a reminder here in terms of the notation that we're using. This means if you plugged in the x value of 4, we got a y value of 16. Okay? Again, I think you'll find multiplying two functions, it's usually like the distributive property or foiling, right? If it's this wasn't a FOIL because I had a line that had two terms, but it was multiplied by a quadratic that only had a single term. Right? The quadratic didn't have a second. But again, nothing really new or super different than what you've done in the past going on there. All right, dividing functions can be a little weird. Not super weird, but a little. A lot of times when you do it, there may not be a ton of simplifying to do. So, all right, find f divided by g. Okay, so f is x plus 3. G is the square root function, so I put it over that. I'm like, okay, there it is. Usually at this point, we take a look and see if the new function that we have can be simplified. And here we're like, nope, it can't. About the only thing you would come across where maybe you would have a little bit of simplifying to do would be if the top or the bottom was like a quadratic and it could be factored, and maybe one of those factors would cancel with something on the bottom. Okay, that's about it. Now, as far as the domain goes, I'm looking down at the bottom. I got two things kind of going on at once. The bottom is a square root, okay? Which means negative numbers are a no-go. So I know right off the bat, so I don't get an imaginary. X has to be greater than or equal to 0. But this one's even a little bit unique that it's a square root on the bottom of a fraction. And the other number that's an issue on the bottom of a fraction is 0. So I actually need to go right here, and where it says greater than or equal to 0, I have to get rid of the equal sign. Okay, 0 is not going to work either. I would be fine taking the square root of 0. Okay? In fact, we're talking about one particular number, so I can just show you. Right? If a number's in the domain, it has to give me a real number as an answer. And I end up dividing by 0. So I'm not going to include 0 in our domain. Okay? First thing we're going to do here is take f over g of 9 and just evaluate it. That would be 9 plus 3 over the square root of 9. Which would get 12 over 3, which is 4, right? Nothing real crazy going on there. You put in 9, you get 4. Check out down here. I'm going to do 9 over g of negative 9. Right now, right away, I'm looking at this, I'm like, okay, we had just established up here the domain is x greater than 0. So right off the bat, I'm like, you're putting in a number that's not in the domain, okay? Which I think is okay for us to see. Okay, because again, based off the definition of domain, we know that we're not going to get a real number as an answer. One of two things could play out. First, that we get basically a y value. I shouldn't even call it a value. It's just y is undefined. We can't get to a number at all. That comes up from dividing by 0. The other piece is that we may get a non-real answer, which is the case here. Put in -9. Nothing really crazy on the top. You get -6. Okay. The bottom, right, because square root 9 square root -1, the bottom becomes 3i. This takes us back to last unit when we did some operations with complex numbers. I get -6i. I squared is -1, so just -3. And I end up getting positive 2i. So even, -9 is not in the domain. It gives me an answer, right? But it wasn't real, right? And again, for a number to be in the domain, it's got to give you a real answer. Okay. Function composition. Okay, you got 2 slides for this one, separate because it's kind of its own separate little thing. Okay, that notation that you see down here would be read specifically right here. F of G of X. Okay. This is that case where you basically plug a function into another function. Okay. The 2 slides we have here, I'm just going to show you kind of the ins and outs of some of those operations. And then on the last slide, show you kind of a word problem where it's like, what situation would come up where you would want to compose 2 functions? Okay, why would that be a thing that we do? And I'll show you that in the last slide. Remember to work, I like to say inside out when evaluating. Work inside out when evaluating, okay? So for example, here's f of g of 4. What happens here is I take g and it's getting plugged into f, okay? So I'd have something like this, okay? There's f, and then 4 minus x squared is going in, okay? It's like g got plugged into f. All right, so now when we put in 4, when I say inside out, what I mean is when I'm evaluating, you're going to have parentheses by plugging it in. So we need to start in here, work with what we would call the inner function, evaluate from there, and then go to the outer function. Like in this case, we'd say inner is g and the outer is f. So evaluate g first, which looks to be -12 plus 2, -10, okay? Here, let's swap the order, right? So now I've got g and f. The entire function is getting plugged into g. And this problem wants us specifically to evaluate at -2. which will get you to 4, okay? Again, my primary concern when you're evaluating is this whole inside out, which means start the process. You're always going to have these parentheses when you compose. So once I put in -2, I needed to start here, get that taken care of, and then work my way to the outer function, okay? Same function on this next one, right? I'm still plugging f into g, which I did in part B, but now I'm just evaluating at 0. So really, I'd start right down here and just say 4 minus 0 plus 2, which would turn into 4. 4 minus 4, which would be 0, okay? Okay, here would be the function f, right? You could compose the same function with itself. F is getting plugged into f, right? So think of it like this. There's the function x plus 2. But what I plug in for x is the function f again. Right, and again, start with the function inside the parentheses. 7 plus 2 is 9, plus 2 is 11, okay? Now the last 2 down here, I'm not going to do any evaluating. I'm just going to get the function itself, which I actually have the beginning of both of them, okay? I actually have that. In part E, okay, it's saying f of g of x. In other words, plug g into f, which I did in part A. Here's function g that got plugged into function f. Okay, all I'm looking for now is just the function itself. So I'd maybe simplify a little bit, but you'll see here that when you compose 2 functions like this as an answer, you get a function. Surprise, surprise. Okay? The parentheses really don't matter. I'd have a negative x squared term out front, and then I'd have plus 6, and that would be my final answer. Negative x squared plus 6. Okay? And again, in part A, I didn't simplify it, but I had that function, and I saw in part A, when I plugged 4 into that function, I got negative 10, but I was using the function that was in part E. Okay? All right, so f or g of f of x, okay, that happened in part B and in part C. Okay, I was using that one. So I'll head back up to right here. The outer function is g, and then I have f plugged inside of it. Okay, this will leave us with a little bit of simplifying to do. Largely because I should expand the second part, the x plus 2 squared, which will become x squared plus 4x plus 4. Distribute that negative sign, so all the signs change here. They were all positive. They then become all negative. I have an x squared term. I have an x term. I have a 4 and a negative 4, so the constants will cancel, and there we go, okay? And again, even though I didn't simplify it on B and C, that's the function that I was working with, right? I saw up here that when you plug negative 2 into that function, you get 4. And when you plug 0 into it, you got 0. Okay, but those are the 2 ways you could do composition. And again, if you're composing 2 functions, those are kind of your 2 options. Say one is called f and the other is called g. You can plug function g into f. You could plug function f into g. Okay, those are basically the two ways you could do it. All right, a little word problem on why you would want to compose, right? And we're not going to use this for, you can see part B. I'll touch on that at the end. We're not going to include it in here to find the time the bacteria count reaches 2,000. If you wanted to take that on your own, it involves solving a quadratic, but to do part A and part B together for one example would just be a little bit too much, okay? But here's what's going on in this word problem. We have two functions, okay? And I'll draw a mapping diagram to kind of show you what's going on. The first function takes little t, which is time, okay? And it gives a model in which we would go from time to temperature, okay? We take the food out of the refrigerator and it tells us for the first 3 hours, right? If the food has been out for this long, here's the temperature of that food now, if it's just sitting out, okay? We have a second one called N of big T, which tells you based off the temperature of the food, how much bacteria is growing on it. It's kind of gross, but good to know, depending on if it's like food at like a social gathering, and it's kind of food that should be refrigerated, but it's just going to sit out for people to like serve themselves. It's okay to be aware that the longer it sits out, that bacteria could be growing on it, so you know that it's out for a safe amount of time. Okay. In a minute, we're going to go over here, and we are going to get N of big T of little t. Okay, or in other words, we are going to take big N, right? This function right here that goes from temp to bacteria, and we're going to plug in the temperature, the time to temperature. Okay, we're going to compose them that way. Here's what will happen. Okay, when you compose them, we would get a new function. That function will go from here to here. Okay, it's kind of like temperature is the middleman. We want to write a new function that says, give me the time. Okay, I'm not worried about the temperature. I want to know if I put in this much time, the function will tell me this much bacteria. That's what our new function is going to tell us, okay? We'll plug in a value for little t, and it will give us N, okay? No longer time to temp to bacteria, just time to bacteria, okay? If you ever have two functions that like A goes to B and B goes to C, and you just want to go from A to C, right, beginning to N, and cut out the middle, that's a case where you would compose two functions, okay? That's when it would come up. So here is big N. I'll tell you right off the bat, this one will have some simplifying, because when you compose two functions, it can vary dramatically as to how much simplifying there is to do. This one has a bunch, okay? So those were big T's. But again, this new function, I don't want the input variable to be big T. I want it to be little t. Okay, so again, this function right here, the +2 is down in the next row, right? That one is getting plugged in. Okay, we're going to compose them. And again, I can put in an amount of time. I still got to stick with the domain, right? Because the domain for little t was just 0 to 3. That doesn't change. This function will only be good for food sitting out for 3 hours, right? It's not that like the bacterial growth would necessarily stop. It's just it would take on a different function for how the bacteria is going to change over time. All right, so here's what we're looking at. We got 20 got to FOIL those two. I can go ahead and distribute the negative 80 right now and get negative 320t minus 160 plus 50. It's a lot of distributing and then a bunch of combining like terms. That's what's coming next, is to FOIL that, which will be 16t squared plus 16t All right, basically 2 steps left. I got to distribute this 20. Like I said, lots of distributing, and then I've just got like terms that I need to combine. So I have 320t squared plus 320t plus 80 minus 320t minus 160 minus 500. 320t squared is the only squared term, so that's going to stay in the final answer. Now we get some other like terms to combine. It will not have a t term. Those cancel. So then we've got the constants with 80 minus 160 plus 500, which I believe would be 420. Okay, so there it is. We've got 320 t squared plus 420. And that would be our composition of the two functions. Okay, so now it wants an interpretation, okay, which is, we've already kind of touched on the interpretation, okay? The number of bacteria right, which we're calling N, is written as a function of little t. That's where we made the change, right? The original model we had, bacteria was written as a function of temperature, right? If we said that the temp of the food, then we could say how much bacteria would be growing on it. But now, it is written as a function of time. Okay, you tell me how long the food's been out, the function will tell you how much bacteria is on it. Okay? That one had a lot of simplifying, right? So to kind of look at each one of those parts, to kind of separate, because I mean, you look at it and you're like, wow, that's a lot. Again, not every composition problem is that way. The big thing up here, check the diagram. Are you okay with the understanding of when and why we would compose two functions? Okay, think of that mapping diagram again to this middleman of temperature. Not interested. We want to function from time to bacteria. Okay, are you conceptually okay with that? Right. Then all the work here, because that concept of the mapping diagram shows up right away in the first line as we plug big T into N, right? Everything beyond this point, that's just one that has an abnormally large amount of simplifying. There's lots of distributing and combining like terms, okay? We'll call it there. One section left in chapter 2, section 7. Topic will be inverse functions.